Welcome back. Today we're going to talk about solving two-step equations, which is just what it sounds like, right? An equation where you're going to do two things to find the solution. So recall that the solution of an equation is the value or the values, right? If you have more than one, that make the equation true. So true statement is something like 3 equals 3, right? You agree that's true. And a false statement is something like 5 equals 2. All right, you'll also remember that inverse operations undo one another, right? So adding, subtracting, cancel each other out. Multiplication, division, cancel each other out. And so we can use these to isolate or get by itself the variable so that we can find the solution. And as we mentioned before, a two-step equation is one where we have to do two operations. So to solve for a variable, we have to apply the inverse operations in the reverse order. In which they were applied to the variable expression. So let's think about this like putting on your socks and shoes for the day. So if I am getting dressed and I put my socks on and then I put my running shoes on and then I tie my shoes, that would be 3 steps, right? So like socks, shoes, tie shoes. Now let's say I am done with my run, I come home and I want to take those off. Well, I don't start by first taking off my socks and then take off my shoes and then untie my shoes, right? But instead, we have to go in the reverse of the order in which those happen, right? So first I would untie my shoes. Well, actually, I probably just kick them off and don't untie them, but let's just roll with it. So let's say I would have to untie my shoes, then I would have to remove my shoes, and then I would have to remove my socks in the reverse of the order in which they happen to begin with. So I have this handy little visual here. Here's our friend GEMDAS, again, the order of operations. So we go top to bottom, right? Grouping symbols, exponents, multiplication, division, addition, and subtraction. When we are evaluating an expression. But when we are solving, we're going to go the opposite direction. So I'm going to get rid of addition and subtraction first, then multiplication and division, then exponents, and then grouping symbols in that order. So let's see what this looks like. If I have this equation here, 3x minus 1 equals 8, I have to first get rid of subtracting 1 before I can get rid of multiplying by 3. So I'm going to add 1 to both sides, and I'll get 3x is equal to 9. Now I have to divide both sides by 3, and I'll end up with x is equal to 3. So again, the order in which we did that was we had to add 1, then we had to divide by 3, and that's how we found our solution. So when we go to check our work, we're going to substitute that back in, and we're trying to see if this is equal to 8, which is why I use the question mark over the equal sign, because we haven't confirmed yet if this is true. Now we follow the evaluative order of operations. So we'll take 3 times 3 first, which is going to be 9 minus 1. And of course that is 8. So that means our answer was correct, that x is equal to 3. All right, let's do another one. So we are trying to get x alone. X right now has a negative in front of it, and then we're adding 7. So first things first, I'm going to subtract 7, right? And the goal there is we're trying to undo addition. So that cancels, and I still have a negative in front of the x. Make sure that you're copying the rest of the equation every time exactly how it should be. So negative x is equal to 5. Now I have to undo multiplication. And I'll do that by dividing both sides by -1. So I'll divide this by -1 and divide this by -1. Okay, x is equal to -5. So when I go to check my work, I'm going to have negative and then plus 7. I'm trying to see if that's 12. I'm going to plug -5 in here. All right, so -5 becomes +5 plus 7. And 5 plus 7 is 12. So that's how we know that our solution of -5 is correct. If we had gotten out something like 18 equals 12, then that's a false statement. And so we would have said, hey, no, this doesn't work. All right, so now we're looking at example 3. So example 3, normally we see our variable written first. It's okay that it's not written first here. We'll still be able to follow the same procedures. So 9 plus x over 5, we're still have to get rid of that adding that of 9 first. So let's go ahead and subtract 9 from both sides. And we'll get x over 5 is equal to 2. Now we have to undo dividing by 5. So we'll multiply both sides by 5. And we'll get the x is equal to 10. And then, of course, checking our work. So we've got x plus something over 5 is perhaps 11. Plug out our solution in here. We're going to carry out this division and get 2. And now 9 plus 2 is, of course, 11. So we know that we did our work correctly. All right, so go ahead and try these 3 out here. So you can solve these 3 equations by following the inverse operations like we've been doing on your own. You can pause the video and then come back and watch them when you're done. All right, so let's talk about what's going on here. So the first thing is I'm going to have to take away 2 since I was adding 2. So now I have -3x is equal to 0. And this kind of always throws off my students. Whenever we get one side equal to 0, they stop writing the equal sign like this. But it's still an equation. It's okay for its value to be nothing. That is a real answer, and sometimes we have quantities in life that are 0. So now I'll divide by -3 on both sides, and I'll get x is equal to 0. And if we check our work, if we plug that back in, we'll have -3 times 0, which will get us 0. And then we have 0 plus 2, which is that 2. So we know that it works out. All right, next one, we're going to subtract 5 from both sides. And we'll have -2x is equal to -12. Now we'll divide both sides by -2. And we'll end up with x is equal to +6. And last but not least, we're going to add 2 to both sides. We have -1/5 x is equal to 6. To undo multiplying by -1/5, we could totally divide by -1/5, and that's totally legal. But whenever you divide by a fraction, you end up multiplying by the reciprocal anyways, right? So I could just multiply this by -5, which is the same thing as -5/1, right? and I'll end up with these canceling, and I'll have x is equal to negative 30. All right, guys, we've done it. We have mastered solving two-step equations, and now we're ready to move on to multi-step, and before you know it, variables on both sides and all sorts of goodies.